This is for Year 12 methods. It comes out of the Chapter 3 review, question number 9 in the multiple choice. A really good question because it demonstrates that what you think are the translations may not be the translations because of the dilations and reflections that happen first. Okay, so I've got 5 of these and I need to pick which one takes this hyperbola back to this hyperbola. Okay, so I can see a couple of things. I might try and get rid of some things or straight away. I can see a negative here. That negative is really affecting the y, therefore it's a reflection over the x-axis, which means that the y becomes negative y. So in this spot here I want a negative. And those 3 I have negatives, but these 2 I don't, so I can get rid of D and E. They're all negative 1/5, so I can't get rid of any of them because they're all the same. I can see that there's a 2 here, but I've also got some translations. I need to think about this a little bit. I know the original has an asymptote at 1/2, and it has an asymptote at 3. Now, if the y value is multiplied by negative 1/5, and all of them are negative 1/5, the dilation and reflection will happen before the translation. So, this is my y, my asymptote. If it gets multiplied by negative 1/5, it's going to go down to y equals negative 3/5. And then, to get it back up to y equals 0, it has to go up 3/5. Therefore, I like this answer and I like this answer because that goes up 3/5. I don't like this answer, so I can get rid of C. So we're now down to A or B. Notice that I could see what was going on by the fact that I read matrices as I see them because they're on the left hand side of my table. So this tells me that the y value gets multiplied by negative 1/5. Okay, so I can do the same thing with this. I have a vertical asymptote at x equals 1/2. If the x value gets multiplied by 2, that would move it over to x equals 1, and then the negative 1 brings it back to x equals 0, and that's exactly what I want because my transformed has 0. If I was to use this one and I multiply it by 1/2, x equals 1/2 multiplied by 1/2 gives me x equals 1/4, and then if I minus 1 from it, I don't get back to 0, so I can now get rid of B. A is the answer because I've interpreted what is going to happen with my dilations, reflections, and my translations. I can also demonstrate that A is correct by using the mathematics of matrices, and that's what I'm going to continue on and do. Okay, so I'm going to prove A. So x dash should equal 2x minus 1, therefore x is going to equal x dash plus 1 all on 2. And y dash should equal negative 1/5 y plus 3/5, which means that y minus 3/5 equals negative 1/5 y. Y is going to equal negative 5. So minus 5y, negative 5, plus 3. So if I've got y equals negative 5 over 2x minus 1 plus 3, that's my original. And the substitutions that I'm going to make will mean that I have minus 5y plus 3 instead of y. And I substitute and I get x plus 1 all on 2. Notice the 2's will cancel. The plus 3 and the 3 will cancel. The x plus 1 minus 1 will give you 0. The negative 5's will cancel to leave x equals 1 on x, and that's exactly what I want.